Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 3.2.4, which is the tangent ratio. And in the first problem here in 3-100, it asks us to solve for the variables in the triangles below, and it says it may be helpful to orient the first triangle so that the triangle resembles a sloped triangle. And what we're going to do is we're going to basically compare the triangle given to the sloped triangle, again, going back to this wonderful resource page that we have right here. So if we look at A, we draw the triangle, we draw the triangle like this, and they're giving us an angle up top here, an angle up top of 79 degrees. Now, actually, there's a couple ways I can go about doing this. If I wanted to, I could actually orient him the other way, that way the W is on bottom and the 12 is going vertical. But I'm already kind of here, so I might as well just kind of keep on going with this. This angle theta here, with this guy being 90 and this guy being 79, that makes this guy 11 degrees off the cuff. Which makes my similar triangle based on my resource page here. It makes it this triangle right here that has a slope ratio of 1/5. So I'm going to go and use the notion of similar triangles with this 11 degree angle right here, this being 1, this being 5. And I'm going to use a proportion to solve for W here. So it's going to be W over 1, if I go from top to bottom, is going to equal 12 over 5. And lo and behold, W is going to equal 12 over 5. So using our good old resource page, that problem turned out to be pretty easy. Let's take a look at B, which is actually already oriented like a sloped triangle. I'll go and just copy and paste him down in the diagram below here. Copy and paste. And then I'm going to go and draw the corresponding slope triangle here. Now, with this guy being 22 degrees, that leaves enough angle right here. If I do 100 minus 90 minus 22, I end up getting 68 degrees right here. And so what I'm going to do is I'm going to draw a 68 degree triangle, or 68 degree right triangle like this. And so from here, with this being 68 degrees, I'll go ahead and look for my right triangle here on the resource page. And that means that my slope ratio is going to be up 5 to the right by 2. Again, this helps me because now I've got similar triangles. I can go ahead and say Z over 2, right, left to right, is equal to 8 over 5. And if I wanted to solve for Z, I would just multiply both sides by 2. So Z ends up being 16 over 5, and that's my triangle B. We'll go and take a look at triangle C right here. Now again, with triangle C, that one's oriented the most weird. So I'll go ahead and reorient him in a pretty aggressive kind of way. And why don't I go ahead and make him look like this instead? That might make things a little bit easier here. With this being the right angle, this thing being theta, and this being 18 degrees. That puts X on bottom and 15 as the rise. Now, with that being the case, I know that my angle here is 72 degrees. Now, again, I'm going to go back to that resource page. Where's my 72 degree angle? That's going to be 3 over 1. Now, notice, I could have oriented him the other way. I could have oriented this triangle this way with the X right here and the 15 down here and made this 18. And notice how that would have been the reciprocal of the other angle that I had right here. See how 18 is 1/3 right here? 18 slope ratio is 1/3, but 72, the other angle, his ratio is conveniently reciprocated. So from here, I'll go and just use the top triangle because I was already there. And I'll go ahead and say, okay, cool. So if I'm doing the 72 degree angle, right here, that means that my triangle is going to be up 3 to the right by 1. Let me just double confirm that and make sure that I'm all good. Yep, 3 over 1. So then again, it goes back to that whole notion of similar triangles. So I'm going to say X over 1, right, left to right, is equal to 15 over 3. In other words, X will equal 5. So this is just to kind of get our feet wet a little bit, back into that whole idea of similar triangles and using slope, angles, and ratios. Again, this works because all of the triangles are similar via angle, at least in the beginning. I'll be back with the next problem. Give me a second. In the next problem here, they're talking about multiple methods of solving a triangle. We've got a team of four, Tiana, Mei Lin, Eddie and Amy, who are looking at the same right triangle, and they're trying to determine that missing side length A right there. In part A, Tiana says, hey, we can rotate the triangle so that 18 degrees looks like the slope angle. So what Tiana is talking about is she's about to rotate this triangle like this. That way 18 degrees creates the slope angle right here. And she says that makes delta y equal to 4. And then that makes delta x equal to A. And it says, will her method work? If we can, then go ahead. If not, explain why. So our slope angle is 18, so I'm going to go back to that resource page and look for the 18-degree angle right here. That means we have a slope of 1/3. Again, I will go ahead and draw that out real quick here, a slope of 1/3 with an 18-degree angle. We're going to use this similar triangle here to solve. So I will go ahead and say 1/4, I'm going right to left, is equal to 3/A. Let's go and cross multiply. A equals 12. Okay, awesome. It seems like it works. We're similar by angle, so it seems like that would work. Now, Mei Lin says I can see it a little differently. I can see delta y is equal to 4 without turning the triangle. How can she tell? Explain one way that she knows. Well, let's take a look at what Mei Lin is seeing here. She's seeing the location of the 4 with respect to the 18 degrees. Now, unlike Tiana, who needed to reorient the triangle so that way she could see the literal rise being 4, what Mei Lin is noticing is that every time you do one of these and you're looking for delta y over delta x, the slope ratio, this delta y always seems to be opposite side from the angle. It always seems to be opposite of this angle here. So let's go and type that into our notes here. When determining a slope ratio, the delta y is always opposite. Actually, I'll say is always the opposite side from the angle we are looking at. And so what Mei Lin is seeing is she's seeing this relationship here. If I go up to this triangle here, 4 is opposite that 18 degrees. It's always the opposite side, right? It always seems to be that opposite side no matter how our triangle is oriented, right? From here, we are going from the theta to the w opposite side, theta to the 8 opposite side, theta to the 15 opposite side. It always seems to be the thing, right? And so, so that just seems to be the pattern that we keep looking at all the time. And then part C, Eddie now jumps in and says, what if we use 72 degrees as our slope angle? And then that means delta x is 4. So here's what Eddie is seeing. If we use 72 degrees, so Eddie, he may or may not be reorienting the triangle, but he puts the 72 degrees here. And then that means that delta x is equal to 4, and delta y is now the mystery. And so from here, what is he talking about? What he's seeing is instead, he's looking at the other angle, and he's looking at the side next to it. And so what Eddie is seeing is, let's see, Eddie is looking at the side that is next to the angle we are looking at. This side is called an adjacent side, right? Adjacent means next to. Okay, and now in part D, we're going to confirm Eddie's observation to answer, again, part A. We should get the same answer here. So if I, again, draw a 72-degree similar triangle, 72 degrees right here. Let's go and look at the slope ratio for that. Slope ratio on a 72, 3/1. So up 3, my delta y is 3, my delta x is 1. Let's go and compare triangles here. I'll go ahead and call this A. We don't know what that is. A over 3, right? Left over right is equal to 4/1. I feel like we're in a similar position here, right? Because no matter how I cut it, it seems like the A is being multiplied by the 1, so A equals 12. I think Eddie and Tiana are onto something. I think Mei Lin is onto something with not even having to reorient the triangle. So at this point, you should be starting to think, what is the relationship that I am noticing between the angles and the sides? And what order does the sides always seem to come in when we are evaluating an angle that we're looking at in terms of slope ratio. That's what you should be thinking about as I move on to the next problem. I'll be right back. And in the next problem here, it gives us a different tool called a scientific calculator, and it says examine the triangle at the right. It says according to the triangle at the right, what is the slope ratio for 32 degrees? Explain how you decided to set up the ratio. Well, again, if we reorient the triangle here, then we have 32 degrees right here with 5 and 8, and then this 9.434 side. And if I look at the ratio for 32 degrees, the slope ratio, so the slope ratio of 32 degrees is 5 over 8, right? Rise over run. And if I wanted to do that in decimal form, that would be 0.625. And then in part B, it says give the slope ratio over the 58 degree angle. Well, again, even if I didn't want to reorient the triangle, I just need to go to the opposite side for the 8 and the adjacent side for the 5. So that would be 8 over 5. And again, I'll just go slope ratio of 58 degrees. And that's going to be 8/5. And again, let's go ahead and put that into a calculator. That's going to be 1.6. And so again, what is this idea? This idea that keeps showing up is this whole, I'm going to the opposite side and the adjacent side, and I'm putting the opposite side over the adjacent side. In part C, now they're saying scientific calculators have a button that will give the slope ratio when the slope angle is entered. In part A, you calculate the slope ratio for 32 degrees to be 0.625. Use the tan button on your calculator to verify that you get approximately 0.625. So let's go ahead and do that on this with this graphing calculator here. I'm going to go and actually, real quick, I'm going to go to the home screen. I need to switch my angle settings here. Let's go and go to degree. And so from here, if I do tangent, now obviously this is a graphing calculator, you guys won't be doing this. You'll be doing it on a scientific calculator, but if I do tangent of 32, I get 0.6248. So let's write that down. So this whole notion of tangent of 32, tan of 32, is approximately equal to 0.6248, right? And so then we're going to verify that, yes, that's about 0.625, right? And then if we do tan of 58, do I get approximately 1.6? Let's find out. So tan of 58, so we go to trig, tan 58. I'm going to go Control Enter because I want to get an approximation. 1.600. I think we're in business. I think we're doing pretty good. And then other stuff. Okay, so that is it right there. And right now you should be making the connection. This is the tangent button. And so from here, we are going to learn about tangent more explicitly and how tangent is used to find the slope ratio of any angle we want to plug in, no longer having to find out that slope ratio from a resource page. So it says in part D, the ratio in the right triangle you've been studying is referred to as tangent. When you want to determine, it is written as tan 32, so the equation is tan 32 equals 5 over 8. Write an equation for tan 58. So that means that tangent of 58 will be equal to, looks like, 8 over 5. And again, the reason why is because they're telling us that tangent of 32 is equal to 5 over 8. And what we're going to soon realize is that tangent is the ratio of the opposite side of the triangle divided by the adjacent side of the triangle. Actually, we're not going to be learning that. We just did. I'll be back with the next problem. And now for the last and final problem here. It says copy each triangle below in your paper, label its legs, and based on the slope angle, and then write an equation such as tangent of 14 equals x over 5 in your scientific calculator to write a slope. Now, notice how they're not giving us numbers that are on the slope table anymore, except for part C. But now that we have a scientific calculator, we can go ahead and find out those values. So in part A, I'll go and say tangent of 38 is equal to x over 8. And now I'm going to go and solve for x. How do I do that? Well, remember, it's just integrated 1. We're just going to try and get x by itself, right? And so I'm going to go ahead and multiply both sides by 8. So now what I get is x is equal to 8 times tangent of 38. And so this right here, this form right here, you're going to be held responsible for on your upcoming quizzes. This is what's known as calculator ready, or sometimes known as exact form, right? Because this is unsimplified. This is not evaluated in the calculator yet. But then when we go to our calculators and put this in, this will be the calculated form. So let's go and find out 8 times tangent of 35. Let's go and punch that in. 8 times tangent of 35. And, oh, the calculator gives me exact form. That's all right. I'll go to Control Enter. 5.601. So 5.601. And this is calculated form. So please make sure you guys are keeping the different forms straight. We will ask you for both of them on future quizzes at any moment. So from here, again, this whole idea here, tangent, and this triangle is oriented a little bit differently, but that's all right. We want to go to the opposite divided by the adjacent, right? So that makes tangent of 73 equal 9 over x. Now this one's going to be a little tougher to solve, because if I multiply both sides by x, that doesn't get x by itself, but it does get it in the numerator, which is helpful. And so tangent of 73 equals 9. I'm going to go ahead and divide by tangent of 73 on either side. So x, tangent of 73. So x equals 9 divided by tangent of 73. And again, this is my calculator ready form. So now let's go ahead and find out what that is in calculated form. So we'll go back to the calculator here, and I'll go ahead and do 9 divided by, and I'll throw it in parentheses because I want to make sure that the calculator reads it. Tangent of 73 degrees, I believe, was the number. So from here, let's go and approximate that. 2.7515. So 2.7515. is the calculated answer, 2.7515, and that's calculated. Okay, let's go ahead and keep on going. Part C, I feel like I'm changing colors for every problem. Why don't I just do C in a different color? So from here, 45 degrees. So again, I can say tangent of 45 is equal to x over 14. So I'll go and multiply by 14 on either side. So 14 times tangent of 45 is equal to x. Now, tangent of 45 is 1. How do I know? Well, it was written in our resource page, right? But if you don't believe me, it's no problem. It's no problem. Let's go ahead and calculate that in our calculators here. So from here, 14 times tangent of 45, boom, 14. Right, because tangent of 45 is 1. Because tangent has a slope ratio of 1 when the angle is 45 degrees. So that pretty much wraps up this lesson. Tangent is a pretty important idea. Trigonometry definitely comes up again in this class, and it'll come up again in future classes very aggressively. So make sure you get our trig ratios in mind. Congratulations, everybody, for finishing Chapter 3. As always, leave comments or questions in the comments area, and I will see you